This is a second video discussing the insertion loss and polarization dependent loss measurement, which is part of the Photonic Application Suite from Agilent. During this video, we'll zero the power meters, perform a reference sweep, measure a device, and then analyze and export the data. Once we've run the configuration wizard to find all the available instruments, we can zero the optical power meter by selecting the Instrument Setup tab and press Run Zeroing. I've already covered the optical inputs, and so I can immediately press OK to start the zeroing process. Once the zeroing is complete, we can go back to the Overview tab and set up the sweep parameters that we're going to use for the measurement. In this particular measurement, I'm going to sweep from 1510 nanometers out to 1590 nanometers, and I'll go ahead and use the default step size of 6 picometers and the default power setting of 10 dBm. The next step is to perform a reference sweep for each of the optical power meter channels. We can access this menu by selecting the port reference configuration, and you'll see all the available channels that are currently configured in the system. I've removed the cover from the optical power meter, and I have the output of the N7700A directly connected to the channel 1 of the multiport power meter, and so I can perform a new reference. The reference for a channel takes about 40 to 60 seconds, and I've just completed the reference on channel 1. I'll go ahead and complete the references for channels 2, 3, and 4, and then we'll connect a device and make measurements. And so the reference measurements on channels 2, 3, and 4 are complete, and I've connected our device, which is a 1x4 DWDM demux, and I'm looking at the first 3 channels of that demux on channels 1, 2, and 3 of the power meter. At this point, we're ready to take a measurement, so I can select OK and press Run Single. And then during a single sweep of the laser, we measure both the average insertion loss and the polarization dependent loss. You can see on the screen right now we're looking at the average insertion loss for the 3 channels of the WDM demux. I also am able to display the polarization dependent loss measurements, and so in this case I just have the first channel's PDL, and you can see within the passband we're able to zoom in and look at the polarization dependent loss on the first filter. There's also a license available to automatically analyze the channel characteristics. We can activate that measurement by right-clicking on the measurement below the workspace and selecting DWDM analysis. The analysis completes quickly, and we can click on the WDM analysis tab at the bottom of the screen and automatically view the channel parameters for each of the WDM channels. This finds things such as the channel center wavelength, the loss at the ITU channel, the channel ripple, among other things that are important. And so the point here is that the user doesn't have to manually go in and try and locate these. All the channel parameters for each of the channels is automatically calculated as part of the WDM analysis. The final steps that we'll review in the video are saving the data and exporting the data. All the data that's been acquired can be saved as an OMR file in the File pull-down menu Save Measurement As, and the OMR file can be recalled at a later date to analyze the data offline. Additionally, we have the ability to export the data both into Excel and MATLAB, and so if we press the Excel button, the IL PDL data is exported directly to Excel. During the course of this video, we walk through zeroing the power meters, taking a reference sweep, measuring a device, and also analyzing the data. Thanks for taking the time to review the N7700A Photonic Application Suite software offered by Agilent. If you have any questions at all, please feel free to contact your local Agilent support. We're here to help. You can reach us in the Americas at 800-829-4444.